So this is our Unit 5, Section 5 notes, where we're going to apply the properties of similar triangles again. So our objective today is to use the properties of similar triangles to find segment lengths and to apply the proportionality and triangle angle bisector theorems. So artists and mathematicians use techniques to make two-dimensional paintings appear three-dimensional. The invention of the perspective was based on the observation that faraway objects look smaller and closer objects look larger. So mathematical theorems like the triangle proportionality theorem are important in making perspective drawings. So we're going to talk about the triangle proportionality theorem now. So if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So you should notice that line EF is parallel to line BC. And as a result, it then bisects, or it actually intersects AB and AC proportionally. So if AE was 6 and EB was 10, and I told you that AF was 3, then you should be able to see that FC is also 5. So 6 over 10 is equal to 3 over 5. So if EF is parallel to BC, then 6 over 10 is equal to 3 over 5. And 6 over 10 is 3 over 5. Now we're going to talk about this, the theorem that proves that. Okay, so we're given that DE is parallel to BC, and then we're going to prove that AD over DB is equal to AE over EC. So first thing we're given is the given piece of information. So we're given that was DE is parallel to BC. Then let's look at this next piece. ADE, angle AD and B, and AEC and C are congruent. So let's go back here and look at the drawing. So ADE is here, and B is here, and AED is here, and C is here. So I know that those two pairs of angles are congruent because they're corresponding angles. So that was our next step. And then if it says angle-angle similarity, we're actually talking about two triangles being similar. So let's go back here and look again. So if we said triangle ABC, we're going from nothing to one arc to two arcs. So it would be similar to ADE, which is nothing to one arc to two arcs. So that would be our similarity statement. Then it says AB is over AD and AC is over AE. That's corresponding sides of congruent triangles are proportional. Then if we talk about this AD plus DB is equal to AB, that's the segment addition postulate. So if we go back here and look, we're talking about AD plus DB obviously equals the whole thing. EC equals the whole thing over there. So that's what we're talking about when we're talking about the segment addition postulate. So let's then work through the rest of this proof. Then we are then just substituting in for AB, we're substituting this in. That's how we got this. Same way over here, AE for AC. That's what that is, substitution right there. Next step, we're just going to then break it apart. So notice that all we did here was broke that there and broke that up there, broke this up here, broke that up there. And the reason we did that is because then notice that we have AD over AD and AE over AE. Well, AD over AD is 1 and AE over AE is 1. So we can simplify that. And then we could just subtract the 1 from both sides to get our final answer of DB over AD is equal to EC over AE. And that's what we were trying to prove. And again, hopefully you know that when you look through these, you're going to be given them as multiple choice or matching or have a word bank, so you shouldn't have any difficulty figuring out what goes where then. This is we're going to find US. So there's a couple ways we can do this. We can put RU over US and set that equal to RV over VT, or we can do it exactly the way it looks in our drawing, which would be RU over So basically the 14 over the 10, RU over RV, and then US over the 4. And a lot of times when I teach this, I tell kids to look at it that way because you can literally see part over part equals part over part. So when I set it up here in my problem, I know that it's given that ST is parallel to UV, so US over RU is equal to VT over RV by the triangle proportionality theorem. So then I'm just substituting my values in. So we did US over 14, that's what they did in this problem, and that equals 4 over 10. Again, doesn't matter which way you set it up. We're going to cross multiply 10 US is equal to 4 times 14, which is 56. Then we're going to divide both sides by 10, so our answer is 5 5/3, or you could say 5.6. That's correct as well. Okay, so now I want you guys to go ahead and try this one and then come back to me when you're done. So here again, we're going to look at our proportions. We're going to use our proportionality. So this time we're just going to do LP over PN, that's what's on the left, and we're going to do MQ over QN, that's what's on the right. We're substituting in our values. We're going to cross multiply. We get 2PN equals 3 times 5, which is 15. And we divide both sides by 2. We get that PN is 7.5. Okay, our next one is the converse of this. And on this one, we are going to talk about if we have two proportions and they are equal to each other, then EF would be parallel with BC. So let's put some numbers up here because I know how you guys think. So if we have that AE is 8 and EB is 2, and I tell you that AF is 4, then we should all be able to see that FC is 1. Again, 8 over 2 is the same as 4 over 1. We could also go left to right. 8 over 4 on the is 2, and 2 over 1 is 2. So there's multiple ways we could move here, but no matter which way we move, we get the same answer, that they are proportional. So here it says if 8 over 2 is equal to 4 over 1, then line EF is parallel to segment BC by the converse of the triangle proportionality theorem. Now we're going to talk about the proof of this one. So when we talk about the proof of this one, we are going to work through this. Obviously, our first statement was our given piece of information. Hopefully, all of y'all see that angle B is congruent to angle B because of the reflexive property. Now, if you notice, we're moving in the opposite direction we did with the other proof. So now we're just adding 1 to both sides. That's just the addition property. Step 4, we're just turning that 1 into what was in our denominator over itself for both sides. And then step 5, if you notice here, we're just basically simplifying it. So we basically put everything over DB and everything over EB, so that's simplify. Our segment addition postulate, again, would be the BD. So we're going to talk about this part added to this part gives us the whole thing. And we're going to talk about BE added to EC equals BC. That's our segment addition postulate. And if you notice up here, when we look at our diagram, we only have one angle. So we know that if we're talking about BDE, let me talk about this next step, step 7. If you notice what we did for step 7, we took AB and we substituted in for this. We took CB and we substituted in for that. That's how we got step 7. And then when we talk about step 8, we're talking about some type of similarity. Well, obviously I only have one angle in the drawing, but I do have both pairs of sides, so we would be talking about side angle side here. And so then once we know that the two triangles are similar, we know that the definition of similar triangles means that all their angles are congruent, so angle D would be congruent to angle A. And then by the converse of the corresponding angles postulate, we could say that DE is parallel to AC. And remember that when we talk about, when we talk about converses, we're always proving that something's parallel. All right, so let's go on to our next slide and let's work a problem. So this one says verify that DE is parallel to BC. So we're going to use again some of our ratios to do that. So we're going to talk about AD being over DB, and then AE over EC. Notice here that we get the same ratio both times. So as a result of that, we can say that DE is parallel to BC by the converse of the triangle proportionality theorem. And yes, you will have to write this out on a quiz or a test if it's given by us. Obviously, it would be an answer choice if it was multiple choice. All right, let's see if you guys can do this one. Now, this one's a little different, but see if you can do it anyway. Come back to me when you're done. Notice here the AC was 36, so that means this has got to be 16. This whole thing was 27, so that means that has to be 12. So once again, when we work this problem, we're going to compare DC to AD, which would be 20 over 16, and EC to BE, that's 15 over 12. That gives us 5/4 for both of them. So once again, we can say that DE is parallel to BC by the converse of the triangle proportionality theorem. All right, our next one is the two transversal proportionality. So this time it says if 3 or more parallel lines intersect two transversals, then they divide the transversals proportionally. So let's see what this one looks like. So if I tell you the AC is 1 and CE is 3, and I tell you that BD is 2, then you should very quickly be able to see that DF should be 6. Again, we could do the 1 over 3 is equal to the 2 over 6, or we could do 1 over 2 is equal to 3 over 6. There are a variety of ways that we can compare these, but we need to move consistently through the problem when we do it. So here it says if line AB is parallel to line CD is parallel to EF, then 1/3 should equal 1/3, and obviously 2/6 is 1/3. So let's work one of these problems. So our problem here says, suppose that an artist decided to make a larger sketch of the trees in the figure, and it gives us the length of AB and BC, it's CD, KL, and then it asks us to find LM and MN to the nearest 1/10 of an inch. So on this one, again, if we look at this problem, we're going to compare sides to sides. So we're given that all these lines are parallel, and we can then say that KL over LM, so that would be KL over LM is equal to AB over BC. That's how we're going to set this one up. So when we do that, then all we're going to do is cross multiply, and I know you guys know how to do that. So when we work through this problem, we get that LM is 2.8. The next one we're going to solve for is MN, and I'm going to use the same ratio I used to begin with because it was our numbers. I don't want to use something that I already solved for, because if I made an error solving for LM and I use it, then I'm obviously going to get MN wrong. So I'm again going to do my 4.5 over 4.1, or I'm sorry, so I'm going to do 4.9 over MN. So here I am, I'm doing 4.9 over MN, and that equals the 4.5 over the 4.1. When I do that, cross multiply, I get that MN was 4.5. Sorry about that. Okay, so now I want you to work this next problem. Now look, there's a couple ways. Again, remember you could do the 2.4 over, so you could do the 2.4 over the 2.6. That's another way to do this, is equal to the 1.4 over the LM. And then when we get down here, it would be the 2.2 over MN. Again, remember, there's a variety of ways to do these, and it doesn't matter which one you choose. So when we do this one, I'm going to do it the same way I did the first one. So this one was 1.5, and then solving for MN, it's going to be 2.4, if I'm not mistaken. Yeah. Okay, our last property that we're going to go over today is the angle bisector. Triangle angle bisector theorem. So that tells us that if our angles up here, ABD, is congruent with DAC, then the sides of the triangle is proportional. So it says BD over DC is equal to AB over AC. So let's put some numbers up here again. So 2 over 3, that should be equal to 4 over, and I think you guys could probably guess, 6. So here again, if angle BAD is congruent with DAC, then 2/3 is equal to 4/6, and it is. because 4/6 reduces to be 2/3. So here we go. We're going to set this one up. So here we go again. So it says PS and SR. We're trying to find. So we got to find X if that's the case. So when we do this one, we could say PS over SR is going to be equal to PQ over RQ, or QR. So that's how we're going to set it up. Going to cross multiply again. When we do that, we get 40x minus 80 equals 32x plus 160. Going to add 80 to both sides, subtract 32 from both sides, so x is equal to 8. I'm sorry, 8x, and then that equals 240. And then x is equal to 30. Then we have to put that back in because the question wasn't asking us for x, it was asking us for length. So PS is 30 minus 2, that's 28. SR is x plus 5, so that's 30 plus 5, which is 35. All right, let's see if you guys can do this last problem. So here again, we could do BD over DC. BD over DC is equal to AB over AC. Recall again, that's not the only way we could set it up. We could set it up AB over BD, AC over DC. Doesn't matter which one you set it up, just as long as you keep it consistent throughout the problem. So here again, we're just going to substitute our values in. When we do cross multiply, when we multiply y over 2 times 8, that's 1/2 y times 8. Half of 8 is 4. And then we do 4.5 times y, that's 4.5y, and 4.5 times negative 2, that's negative 9. Subtract 4.5y from 4, that's negative 0.5y, and we're going to then divide that into negative 9, so our answer here is going to be 18. Then we have to plug that back in again, remember. So AC would be 18 minus 2, and DC would be 18 divided by 2. So